Hello. In a recent tweet, I mentioned that Jupyter Notebooks can be quite beneficial for forensic investigations. So when we do forensic investigations, there are quite a few challenges that we're facing. So first of all, we need to document very well what you're doing. We need to document very well what results our actions rendered in the end and things like that. At the same time, the data that we're working on in forensics tends to be large at times, right? So we don't want to store that forever, which means the documentation even needs to be better than if we would retain the data for a long time. Secondly, we do have a problem with new analysts, right? We need more people than the industry currently gives to us. So for that reason, if you want to give guidance to people, Jupyter Notebooks are also a way to make them understand the investigation process in different analysis scenarios. So starting right away, I use that for a memory forensics use case here, and that's just how I'm going to show you what I mean with having the documentation for the actions that we took, as well as the results that our actions rendered in just one simple sheet, right, for reporting in the end. So let me just show that to you. I set up Jupyter Notebooks and Volatility 3 already. I will put some commands into the description of that video to guide you on how to install those tools, but it's pretty straightforward. So for Volatility, all you need to do is basically clone the repository and then just run the Python script. You need Python 3 for Volatility 3, but that should not be an issue on any modern Linux system. So I'm currently running, I think, on Ubuntu 20 something. The same goes for Jupyter Notebooks. So Jupyter Notebooks can be installed with pip. So pip, that's the Python package manager. And now that you installed Python, it's very likely that you already have pip installed as well, and everything is running. You just start up Jupyter Notebook, and it usually starts listening on localhost on port 8888. And then you just connect to it, and this is what you're gonna um, be confronted with. So you got a file browser. You can see that I got like two memory images in different formats, got some node modules here. And what I also have here is a IPython notebook here, right? So this is this IPYNB thing. And I just called it memory triage template. So that is something I can prepare in advance to go through the necessary steps for memory forensics, right? So there is like a 5 or 6 step process depending on which class you took. And that allows us to find malware and injected malware pretty easily in any memory image, right? So this is something we can pre-plan because the steps are always the same, and we can describe what we're doing and why we're doing it. And let me just show you how the process would work now if I have another analyst who I need to go through the same process. So what you can do is I might just call that a template. So that sort of indicates that I probably want to keep that and just create a duplicate of out of that. So here's the duplicate, and I just call it like the image that I'm gonna investigate. So that's the Crydex image, for example. Let's just see how far we get. So it's now called Crydex. Let's open that up. And this is what it is. So basically, the cool thing about Jupyter Notebooks is that it can mix markdown, like here, so I can put in some descriptions together with code. And that code can be Python code, but it can also be command line code. So for example, I don't know what my memory image is called at the moment. So what I have here is one line where I can put in command line commands like ls to figure out the file name. And as you can see, it brings up the same examples pretty much that I saw in the Jupyter Notebook file browser here, right? So it's the same content here. But now I can just copy out that name here because I might need that for the next commands. And then I already start describing what we're doing and why we're doing it. So the step one is that we want to target malware that is running in its own process. So how does that malware usually hide? Well, it, for example, tries to hide by mimicking legitimate applications, right? So malware authors might just pick names like SVC host, Explorer, or whatever, right? And in most of the SANS classes that consider memory part of a class, we do go through some sort of process to figure all the different data points of a process out that we can use to figure out if it's better or not. And in step one, we are usually looking at three different ones. So we're looking at the executable name. Is it really SVC host, or is it something that's just similar to SVC host? So maybe the O is replaced with a 0 or something like that. Then we'll look at the process parent. So who should normally be starting SVC host? It should normally be services.exe, right? So this is what we look at, and the start time, but not the start time in an absolute manner, but we're looking into the start time relative to the start time of other processes or the boot process, right? So in a nutshell, the boot time is very close to when the system process starts, right? So that is our reference there. Now, as you can see, I described all that I just told you about here, just in a few sentences. So a new analyst can read through that. And I have the command with me here as well. So I installed volatility in this directory. This is the image. I just prepared that. And to get the easiest way to get a nice view on all three of them is just using the ps3 command. So let's just run that. And as you can see, I have the description, I have the command in the exact manner that I used, and I also have the results. And now you can see I got a problem because the lines keep breaking, right? Where I don't want them to break. So, well, it works pretty well, but we can make it a little bit broader. So I prepared just a little bit of extra code down here that resizes that a bit. I can also reference that code in the detail section, in the description section of that video, because I find it quite useful if you can just make that Jupyter Notebook window a little bit broader, because you might have some requirements for space. Let's look at that. So it's a very typical startup. It's a Windows XP image. I just picked that one because it's super small and it's fast, and it's not about memory forensics per se, but just demoing the Jupyter Notebooks thing here. That's why I picked a very old XP image. Okay, as you can see, services starts all the SVC hosts. So based on that, nothing seems too odd, right? So maybe we need to proceed here with that image. So the next thing that could basically get me into trouble with that approach here is PS3 uses PSList under the hood. So in memory process, metadata is linked to each other's process, right? So it's like a doubly linked list that that PSList walked through, and PS3 builds on top of PSList, right? So there is a way to hide processes by taking them out of the doubly linked list, right? It will still work. The processes will still keep running, but they will not show up any longer in the task manager, for example. And it will also not show up in the PS3 command. For that, there is a second command, and that is called pscan. So what pscan does is memory is organized in Windows, is organized in so-called memory pools, right? And there are certain pools where e-process structures, so those are the management structures for processes, where they are stored, right? And that thing, that pscan, scans for this specific e-process structures. So this is what that does. So let's see if we find more processes with that. So if you want to run it right away without always clicking up here, what you can do is you can just punch the Shift and Enter key, and it will start right away. That makes you faster. You can also use the Tab key to walk through the different blocks. As you can see, there's not too much different things, right? So no real other processes in there that we should be interested in. So we don't see any suspicious processes here. That brings me to step number 2. And step number 2 gives me the second set of 3 different parameters I'm interested in a process, which would be the command line, the executable path. I mean, you could have an SVC host malware that just happens to be in a directory where there is no real SVC host. I mean, I can call my malware svchost.exe all day long as I don't put it in the Windows System 32 directory, right? And we're interested in the process owner, so that might also be interesting. Here again, we have the descriptions, and I'm particularly looking for one process now. So going up here, so what I'm interested in is the 15, what was it? I think it was 1588. Which is that Windows update kind of process here. So let's look into that real quick. I could have picked every process. So if you get rid of that PID parameter, for example, well, you get all the processes. And again, I can describe what I'm doing here, right? So even a very unexperienced analyst can work with that. So let's start that right away. Volatility is crazy fast, by the way, so it's really working well. So as you can see, the command line is pretty easy in that regard because there is just no command line arguments for that process. So I would be interested also where that is stored. Not for every process you will see the full path here necessarily. There's another command which is called DLL list. So that shows me the loaded DLLs as well as the executable itself, which should be the first line. So this is the actual executable path, the full path to the executable. This is what what DLLs it loads. So that could also be interesting because that's kind of poor man's malware analysis, right? Because by looking at what libraries a certain piece of software loads, you get an idea of what capabilities that software might have, right? Now, let's see who started that Windows update process, right? So we're interested in the user, and for that we have the get sits command, get security IDs. That runs a bit longer sometimes, so it's very fast in Volatility 3 now, especially on small images. The reason why it takes a moment to run is that get sits extracts the registry hives to basically give the sits a name, right? So basically they extract the real usernames because that is more handy for further analysis than the actual user SID. Usually I record both because I'm interested in both. Okay, as you can see, the user for that one is Robert. So with that ID here, and he appears to be a local administrator. Okay, so basically the first line indicates the user, and all the other lines indicate which groups this user is a part of, right? So let's look further and see what other processes Robert started. We can do that this way, get sits for every process, and just pick the one where we have Robert as a name. So apparently that is the person who started the Explorer session. Update, I think that's the reader update, the old Adobe Reader or something, I'm not sure. And some update, Windows update stuff here, I think that's this one. Okay, now that's a point where we break, where we need to break. The next step would be looking at the network things. Now the problem is with Volatility 3, I cannot do that with conscan for Windows XP images, right? But this is a Windows XP image, so I have to skip that. I mean, I can show you real quick. That will run into troubles, right? So, well, actually, I got a problem here. I don't know why. Windows, something is off because it should give me an error message here. Let me just check that out real quick. What's going on here? Because it really doesn't work for that. Oh no, I know what I did. I used the old Volatility 2 syntax here and didn't replace it. So it's actually netscan for Volatility 3. As you can see, it knows what netscan is. But it also breaks because it says this version of Windows is not supported. Never mind, we'll look at another one, and that is the malfind one. So step 4, now when we have the first 3 steps, we look into more the injection kind of thing. And one of them, and that's where we probably hit on the malware, is malfind. So malfind looks at, I would say, mislabeled memory sections, right? So it looks for memory sections that are executable and writable, but at the same time have no backing on the hard drive. So that's what it does in a nutshell. It's a bit more complicated, but this is what it does in a nutshell. And then it brings up those sections. So let's do that real quick. As I said, the image is really small, only a couple of 100 MB. And as you can see, it shows you all of these sections, this time in a scroll box. When I look through all those sections, I have a WinLogon process that has something injected. It's all or mostly zeros, as you can see here. It doesn't mean it's not bad. But let's see if we got a quick win here. So let's just keep moving and scrolling through that. And I think eventually, like here, we see that we have an explorer.exe process that has mislabeled sections without backing on the hard drive, and they start with an MC header, right? So there is a DLL loaded right into memory where it shouldn't be. So probably that is what the malware is doing. It injects, in that case, into the Explorer process. Well, that gives that malware quite some powers because remember, and that's good because we have documentation here, remember the Explorer process was running under the user Robert, and we also know is that user Robert is member of the administrators group, so it's a local administrator. So that means we found our malware. early on. There would be more things to do, but it's not about memory forensics mostly here. And the cool thing is we now have everything we did. We have the description of why we did it, and we have even the results of that. And now I can start and can basically say, okay, let's put a print preview here. Takes a moment. And there's everything together. And I can just store it as PDF or whatever I like. And I have my full documentation together with, well, all the commands, results, and so on. And this is what I meant when I said Jupyter Notebooks can be very helpful, not just for documentation, but also for training, right? Because a new analyst will now get an idea of how to work on this 5-step process to find the malware. So very short video. Thanks for watching and see you next time. Bye bye.